In this video, we are going to discuss how to use the unit circle. If you haven't watched the videos before this one, I would recommend going and watching them. The last four will piece all of this together. So this is the end goal. You're not going to have a unit circle like this all the time. You're going to draw your pictures, but I want you to notice that these have all the angles in there, right? The pi over 3, pi over 6, 4, pi over 6, those are all there. What we're going to do is I'm going to show you what is the point. Why are we doing this? What is it going to look like in this class using this? What is it going to look like when we get to calc? This is what we're going to be given. In the middle of a calculus problem, you're going to do all this calculus, and you'll get to this point, and you got to be able to do that. If you can't do that, you won't be able to move forward. Now, there are calculators that will do this for you, but not every university lets people use calculators. For instance, I used to work at University of Arkansas. All of their calculus classes did not allow a calculator, which means you would have to know these to be able to move forward on problems. So I think it's really, really important to know how to do this. Okay, so we're going to do all 16 of these. Let's do sine of pi over 6. So the first thing I start with, I'm going to write these out, and I'll write less notes as we go through, because eventually we're going to move to doing it in our head. So pi over 6, what you're going to do, okay, pi over 6 is in quadrant 1. Okay, cool, I know that. Pi over 6 is also my short triangle. So my short triangle, this is a 1/2, and this is a radical 3 over 2. Well, based on what we've been doing, sine is y. So if I look here, the y measurement would be 1/2. And we are done. That is sine of pi over 6. This picture here that I have here, I have some teachers that do, and you may have had a trig class when you were in high school. They make you like memorize the whole thing and they would give you this blank thing here and make you fill it out. That is not useful in my opinion. The reason I'm saying that is because in your Calc 1, 2, 3 courses, you don't have time to draw all this. Time is a virtue with test, like 1,000%. And as you go up, tests get harder to finish. So we need to be quick at this kind of stuff. So that we can draw that whole unit picture, or we can do what I just did down there. We're still using the unit circle, except for we're just taking the information that we actually need and putting everything else to the side. Okay, so that's how we do that one. Let's do cosine. So I erase this. Okay, cosine of pi over 3. Okay, pi over 3, that's quadrant 1. And then also, this pi over 3 is our tall triangle. So my tall triangle is going to be a radical 3 over 2. This is going to be a 1/2. Okay, cosine, remember, cosine is x. So it's 1/2. That's how we go about it. The problem is if you don't know where your angle is, which quadrant, you can't do it. If you can't tell me if it's the short, middle, or tall triangle, you can't use my method. If you don't know the sides of your 30, 60, 90 triangles, you can't use my method, right? You got to have all three things lined up. And great. But the good thing is about a method like this that I'm showing you, here's the scaffolding steps that you got to get down, is you have an end goal. You actually have something. I know for sure that this works. I've been doing it for a long time like this. My students that even Calc 3 students had different trig professors. I showed them this and they're like, oh my gosh, that's much easier. It just takes time that you got to pour into it. Okay, let's keep going across here. Let's go down actually. So let's go down to the sine of 2 pi over 3. So what I do, okay, 2 pi over 3. 2 pi over 3, if I think about it, that's in quadrant 2. And pi over 3, right, is going to be my tall triangle. So this is a radical 3 over 2 and a 1/2. Now, here's the part that is the tricky part. This is in quadrant 2, so x is negative and y is positive. And that's how I keep my positive negatives. I know in what quadrant x is positive, y is negative, because we've been graphing that way for a long time now, right? So sine of 2 pi over 3, I have that triangle there, and I know my sine is y, so it's radical 3 over 2. If I had to do cosine, I would do negative 1/2. But we don't have, I don't think, let's look to see if we have another 2 pi over 3. I don't. I think I tried to do a bunch of different ones. All right, so that's how we do that. Let's do cosine of 5 pi over 6. Okay, 5 pi over 6. Okay, that's quadrant 2. And over 6, those are short triangles. So I know this is radical 3 over 2, and this is 1/2. I also know that the radical 3 over 2 is negative because it's to the left. 1/2 is positive because it's up. And cosine is, if we have our variables, cosine is x. So this is negative radical 3 over 2. We can do that completely by establishing which quadrant it's in, which triangle it is, and then filling the sides out. All right, so looking here, and eventually where I'm at, and I've done quite a bit of math. I have a master's in pure math. I don't draw pictures. I don't even write what we're writing down anymore. I just think, okay, it's in this quadrant, and in my head, I'm just thinking about it. But I also have done a lot of math, but you can get there too. But I like this method. We're barely writing anything down, and we're going to get through a bunch. Okay, sine of 7 pi over 6. 7 pi over 6, that's quadrant 3. And then 6 is my short triangle. So to make it short, this would be radical 3 over 2. This would be 1/2. And both of these are negative. The x is negative because it's to the left. The y is negative because it's going down. Sine is y. So I just do a negative rad 3 over 2. Pretty straightforward. Okay, 3 pi over 4. These do take practice too, so if it feels a little hazy, that's okay. Just know that you're watching somebody that's done it for a long time, so of course it's going to feel easy while you watch somebody. You're going to just have to put the reps in like I have to put them in. Okay, 3 pi over 4. This is quadrant 2. It's an over 4, so I know that's a middle triangle. So it's right in the middle. These are the same, and both sides are radical 2 over 2. So I know those are there. I know the x is negative and the y is positive because it goes left and goes up. Cosine is our x, so this is going to be negative rad 2 over 2. All right, we got 2 more, and then I'm going to throw a wrench in it. I'm going to make it a weird problem. Okay, pi over 4, that's pretty straightforward. Pi over 4 is quadrant 1. It's also our middle triangle, right? It's mid. And then I draw my triangle. I know the sides are the same, so each of these are rad 2 over 2. And they're both positive because they go to the right and up. So sine is y, so it's rad 2 over 2. All right? Let's do the next one. I got 11 pi over 6. That's quadrant 4. And I know that is my, since it's 6, it is a short triangle. So this is rad 3 over 2. The short side's 1/2, but it's going down, so it's negative. Rad 3 over 2 is positive because it's going to the right. Cosine is our x, so this is rad 3 over 2. All right, so that's how we deal with it with the special triangles that we have. Again, I do want to point out that this is a lot. Please give yourself grace if it's not clicking right away. And again, if it's one of those things, and I hear this a lot from students, like, well, when I watch you, it feels easy, I can follow. Well, of course, I'm leading you. What you need to practice is you need to make up a bunch of random ones like I have here and go through them. And you can always type these into Google to check. Right? Not all calculators will do these exact. There are a few. I will show you those towards the end of the semester. You won't be allowed to use them on test until one part of the end. I think the final, you'll be able to use one of those calculators on a part of it. But the goal is to be able to do it like this because it's going to help you be better at calculus. Of course, the calculators exist, but again, if you don't know what you're doing, once you guys get up to the big physics courses and the big Calc 3 and Diff-EQ, you're not really following algorithms anymore, meaning like a method. There are methods, but it's a lot of like using your eyes and geometry and using intuition that you have. So this is how you get better at logically thinking through things, are methods like this. They're painful for sure, and they take reps and practice, but I believe you can get there. Okay, I got a couple of weird ones. The next 4 are a bit weird, and then we'll finish with 4 regular ones. Okay, pi over 2. We didn't really do any over 2s, did we? We did over 6, over 3, over 4. Pi over 2, if I remember where that's at, right? We got to know where it's at. It's straight up right here, right? Well, we're dealing with a unit circle, so we have a circle here, and the radius of the circle is 1. So if I just think about that point as x's and y's, it's a 0x and a 1y, right? Like that's where the point is. Let's look at our unit circle real quick. This point right here, since the unit is 1, this point is 1, 0. X is 1, goes to the right, and it doesn't go up and down. Right here, this point is 0, 1, because it goes left and right 0 and goes up 1. This point here is negative 1, 0, because it goes to the left 1, negative 1, and 0 up and down. And then our last one here is 0, negative 1. Well, you know how we said that sine of theta of any angle is going to be the y, and that cosine of theta is the x? Well, that applies to these points. So when I have this pi over 2 down here, and I recognize the point is straight up and down, and it's 0, 1, Sine is y, so my answer is the y value. It's just the 1, because that's the y value going up to that point. All right, for pi, for cosine over here, that's over here. Well, this point to the left is going to be negative 1, 0. I don't memorize these. I just write them. I ask myself, where does it go? It's negative 1 to the left and 0 up and down. For pi, that's over there 180 degrees. Remember, cosine is x, so the answer is negative 1. 2 pi all the way around. Okay, I'm just going to draw it on the same axes right here. That's this point. This point is 1, 0. So the sine, which is y, of that 2 pi all the way around, landing there again, is the y, which is 0. I got one more with this cosine of 3 pi over 2. I'm going to put it right here. 3 of pi over 2 is straight down. We have that point, 0, negative 1. And we're dealing with cosine, so that's the x value, so the answer is 0. It's pretty straightforward if you know sine is y and cosine's x. All right, let's do 4 more of the style that we scaffolded towards. Sine of 7 pi over 4. Okay, 7 pi over 4. That is quadrant 4. And it is our middle triangle. So I know those are both rad 2 over 2. Oh, I didn't even draw the triangle right. And we want to put it in the right quadrant. Quadrant 4, so it looks like this. And they're both equal, so this is rad 2 over 2. The reason I put it in the quadrant is because the positive, negative stuff. Okay, x is positive, the y is negative. Okay, we're looking for sine. Sine is y, so this is negative rad 2 over 2. Cosine, okay, so we have that one. So sorry about that, my bad, it's about to die, but I'm about to be done. Cosine of 5 pi over 3. 5 pi over 3. Okay, where is that at? 5 pi over 3 is quadrant 4. So, and we're dealing with over 3, so this is our tall triangle. So this is rad 3 over 2. And this side is 1/2. And then I know I go down, so that's negative. But we don't care about the down one because we're dealing with cosine. Cosine's to the right, so this is 1/2. All right, we got 2 more. You can see the repetition in this, but the only way to get good at repetition is to repeat it. All right. Okay, pi over 3. That's a pretty easy one. That's quadrant 1. Pi over 3 is my tall. So this is rad 3 over 2 here. And 1/2, since it's in quadrant 1, they're both positive. Since we're dealing with sine, it's the y. So it's rad 3 over 2. And then we got one more, cosine of pi over 6. That is my short triangle. To make it short, that's a rad 3 on top, on bottom, and a 1/2 going up and down to make it short. And we know cosine is our x, so it's rad 3 over 2. So like I said, I want to say it again, and you're going to hear me say it quite a bit of times. Give yourself grace on this. This is not an easy thing because there's so many parts. Especially if you just watched it straight on the day that things are due, you're not going to have a great time with this. Please do not get in that habit. I know I'm the professor in the digital world right now saying this. Of course, I'm going to say don't wait till the last minute. But please trust me, when you let mathematics wait till the last minute and you're trying to get your homework, it's just going to lead to frustration. Unless you're just like, this is easy, I've already had this down quite a bit, I've already done some of this, and it's just straightforward. But otherwise, please do not do the disservice of yourself of waiting till last minute for mathematics. It's not fun. You're not giving your time for your brain to process. You're making a situation that could be not so bad, and you're making it much worse by waiting till last minute. And that's just because mathematics takes time. So get the practice in, make your own problems up, check them on Google, keep watching these videos to get refreshed on it. This method is probably, I say, out of all the topics that we're going to cover in trigonometry, there's like 3 or 4 that I think are most important for the calculus STEM series. This is number 1 out of importance. And I know it's crazy because we're doing it day 2, but this is the most important thing that we will do. Setting you up for the rest of your STEM journey. Those of you that are taking pre-calc 2 and you're done, you just got to get through this course. But let's improve our critical thinking by working through logical processes like we have in this video.